China just whipped up the world's first silicon-free chip. Yeah, you heard that right. This crazy invention is already giving tech giants like Intel and TSMC a run for their money. How did China get here, and what does this mean for people like us? For 70 years, silicon has been the undisputed king of semiconductors. You take silicon, heat it, slice it into wafer-thin discs, etch tiny circuits onto it, and you have a chip. Your phone, laptop, gaming console, and even the servers running the internet all rely on it. Silicon is cheap, abundant, and versatile, which is why it became the backbone of electronics. But over the years, engineers and scientists have been hitting the limits of what silicon can do. Chips are demanding faster speeds, better energy efficiency, and less heat. We are pushing silicon to its breaking point, and experts have been hinting that the silicon era is running out of steam. China, already a global tech powerhouse, decided to look beyond the limits of silicon. Rising tensions with the United States and disruptions in the global supply chain gave researchers there the incentive to innovate. Instead of following the traditional path, some of China's top labs and semiconductor companies asked themselves a simple question: what if we do not need silicon at all? That question sparked a wave of experiments with new materials and chip designs that had never been tried on a large scale. What came out of it is a chip built from gallium oxide, a material that is abundant and has properties silicon can only dream about. Making a chip without silicon is not a simple swap. You cannot just replace one element with another and expect the same results. It is like trying to play a new sport with the rules of an old one. Every step, from design to manufacturing, had to be reimagined. The engineers had to rethink the architecture, power management, and heat control from the ground up. It is a fresh start in a field that has relied on silicon for decades, and the results are stunning. The performance of this gallium oxide chip is impressive. Early tests show it running 20 to 30% faster than top-of-the-line silicon chips while using far less power. It can also operate at higher temperatures without needing the bulky cooling system silicon chips often require. This means no more laptops that feel like heaters after an hour of gaming, or data centers that consume enormous amounts of energy just to keep the servers cool. Devices built with these chips could run more efficiently, faster, and cooler, all at the same time. Beyond raw performance, the new chip also offers a solution to manufacturing challenges. Making silicon wafers is a complex, expensive, and fragile process that depends on a long global supply chain. Shortages and disruptions in recent years have shown just how vulnerable it is. Gallium oxide is different. It can be sourced and processed in ways that avoid some of the bottlenecks that plague silicon chip production. Think of it like the difference between a car that needs rare fuel and one that runs on something almost anyone can access. Gallium oxide chips are faster, more efficient, and easier to scale in production. The implications go far beyond tech fans and engineers. Intel and TSMC have dominated the chip market for decades, pushing silicon technology to its limits. But a material switch like this challenges the assumptions everyone has made about the future of computing. It shows that Moore's law, the principle that chip performance can keep doubling, might have a new chapter, or even a whole new story. It forces the global tech industry to reconsider what comes next. Of course, there are challenges. Silicon has decades of refinement behind it, and manufacturing at an industrial scale is a well-oiled machine. Moving a new material into mass production is never simple. China is currently running pilot factories, scaling up slowly to meet potential demand. It is a careful balancing act, but early results are promising enough to suggest that this chip could make a real dent in the global market. The geopolitical angle is just as interesting. The semiconductor industry has long been a battleground between China and the United States. Export controls and trade restrictions have slowed China's access to advanced manufacturing tools. But creating a silicon-free chip could be China's way of saying that it is not dependent on existing supply chains or foreign technology. If this chip reaches the consumer market, it could shift power dynamics in global technology, making countries rethink their reliance on silicon-based products. For everyday users, this is exciting. Devices that run faster, cooler, and with better battery life could change our day-to-day interactions with technology. Phones could last for days without charging. Laptops could remain light and portable even under heavy workloads. Data centers could save massive amounts of energy, and we might even see entirely new devices that silicon chips could never handle efficiently. The practical effects are huge, and the possibilities for new tech are endless. Silicon is not going away overnight. It is deeply integrated into the electronics ecosystem, from chips to devices to infrastructure. The most likely scenario is a coexistence where silicon handles some applications while gallium oxide chips excel in others. It is not about replacing one with the other immediately, but expanding the toolkit engineers have to work with. Each material has strengths and weaknesses, and the future will probably see them working together to power technology in new ways. This breakthrough is also a story about design philosophy. The researchers did more than just replace silicon with gallium oxide. They redesigned chip layouts, rethought data flow, and optimized power usage for the new material. It is like giving a new athlete a new playbook instead of trying to make them fit an old one. The combination of material science and architectural innovation is what allows this chip to perform so well. It is a reminder that breakthroughs are rarely about one thing. They happen when multiple disciplines come together to solve complex problems. Collaboration across fields has been critical. Chemists, engineers, software developers, and manufacturing specialists all had to work together to make this chip a reality. This is a great example of how modern innovation does not happen in isolation. It thrives where different areas of expertise intersect, producing solutions that would not be possible within a single field. The result is a chip that is as much about human ingenuity as it is about a new material. Looking ahead, the technological possibilities are massive. Gallium oxide chips can handle higher voltages and faster processing, which could have huge implications for electric vehicles and renewable energy systems. Electric cars could process complex systems more efficiently, giving better performance and range. Solar and wind systems could benefit from improved power management, making renewable energy more effective. These chips could enable a wave of innovation that extends far beyond traditional computers and phones. China's silicon-free chip is more than just a technological achievement. It is a bold statement about the direction of global innovation. Instead of following the established path, China is daring to rethink the rules entirely. It is part of a growing wave of experimentation with new materials, new designs, and new ways of thinking about the devices we use every day. This is how revolutions in technology happen, by questioning the fundamentals and building something entirely new. On a personal level, this development is exciting. We often take incremental improvements for granted, but breakthroughs like this remind us that rare, radical changes are possible. These changes can shift industries, redefine markets, and open doors for entirely new technologies. The excitement comes not just from what this chip can do today, but from imagining what comes next in a world where silicon is no longer the only option. The impact on global power dynamics is also significant. Controlling semiconductor technology is no longer just about making faster chips. It is about influence, security, and independence in an increasingly digital world. If China can scale these chips and introduce them internationally, it could challenge long-standing hierarchies and give countries new leverage in technology and trade discussions. The stakes are as high as the technology is advanced. For consumers, the near future could be thrilling. Devices could be smaller, lighter, and more powerful while using less energy. Laptops, smartphones, tablets, and even gaming systems could see improvements that seem incremental today, but become transformative over time. The combination of efficiency, speed, and heat management could reshape our expectations for electronics and how we interact with technology daily. The gallium oxide chip also demonstrates how breakthroughs require a holistic approach. The material is just one part of the puzzle. The design, architecture, software integration, and manufacturing process all had to work together to create a chip that performs as well as it does. It is a reminder that innovation is rarely about a single discovery. It is about putting multiple discoveries together in a way that amplifies their effect. As the industry watches closely, it is clear that the arrival of silicon-free chips could redefine what it means to build computing devices. The next generation of laptops, phones, and data centers might look very different from what we are used to. Energy efficiency, heat management, and processing speed could all take huge leaps forward, and that is just the beginning. With new materials and new approaches, we might even see entirely new categories of devices emerge, ones that silicon chips could never have supported. In the end, this chip is more than just a technical achievement. It is a signpost pointing toward the next era of computing, one that could change everything from personal electronics to global technology power. The journey from silicon to gallium oxide shows what is possible when scientists and engineers refuse to accept limits and look for new ways to solve problems. So there you have it, a chip without silicon, faster than anything Intel or TSMC currently offers, built from a new material and backed by vision, innovation, and a willingness to challenge the status quo. What do you think about this new Chinese silicone-free chip? Would you rather use a silicone-free device or stick with the old? Leave your thoughts in the comments down below. Don't forget to like and subscribe. Till our next video, bye for now.